Let's look at a couple of examples of functions that are defined numerically. The function f, we'll start with here, is defined with a series of ordered pairs. You can tell this is a set because we start with a brace, and then each element of the set, which is an ordered pair, is separated by a comma. So there are 5 elements of the set. They're each an ordered pair. Now, the ordered pair is defining how an x value gets translated to a y value or mapped to a y value. So in this first ordered pair, 0 maps to 4. Remember, our domain is going to be the set of x, or the set of first values in the function. So again, it's a set, so we're going to start with a brace, and we have individual values, specifically 0, 1, 2, 3, and 4. Those are the domain values. They're the x values. The range would be the set of second values, or y values. Now when we look through those, we have 4, 3, 5, 3, and 5. 3 and 5 appear twice. Typically in mathematics we list those in order. So the 3 would come first, then the 4, then the 5. You do not have to list duplicates in your set. So the domain would be the set of x values, the range would be the set of y values. In our second example, we have a function p defined by a table. The input of p, if we look at the notation, is x because the x is inside the parentheses. Now recall correctly that when we evaluate a function at an x value, we are finding the y value. So we have x values in the column on the left and corresponding y values in the column on the right. The domain would be the set of all of the x values. So again, they're listed individually, so we list them that way as a set. So -3, -2, 0, 2, 3, and 5. So there are 6 values that are contained within the domain. The range would be the set of y values. Again, we generally go from low number to high number, although I wouldn't mark you wrong on a test or a quiz if you showed them in any order, as long as you get them all in. Range, -1 would be the lowest value in this grouping of y values. The next lowest would be 3, the next lowest would be 5, the next, or the highest, would be 7. Notice, I don't list out 3 more than once. It only has to appear once. And same thing with -1. Even though -1 and 3 appear more than once in the table, you don't have to show them as duplicates in the range. So the domain has a set of 6 values, the range has a set of 4 values. In the next example, at the bottom of the page, we have a function that I've called g, and it's defined by these points on the graph. Notice those points aren't connected, so this function literally is just those 5 points. I could actually list them out if I wanted to. I could put their values right next to the point. The first point would be at -5, 4. The next one going to the right would be -3, 2. The next one over would be -1, 4. And then continuing to the right, 2, 3. And finally, we have a point here on the x-axis at 3, 0. When you see them as ordered pairs like that, it becomes just like this problem up above. We have a set of 5 ordered pairs. If we wanted to show the domain, we're going to show the x values. So the x values, just from left to right, starting with the lowest, would be -5, -3, -1, 2, and 3. Then the range would be the set of y values. So that would be, this time I'll start low, so the lowest y value is 0, then 2, 3, and then 4 appears twice, but I don't have to write it twice. So there are 3 examples where a function is defined numerically. This last one, it's actually defined graphically as well.